All right, I'm going to see if I can use Google Sheets and Google Docs to do the kinds of things that you're supposed to do for Lab 2. I'm not using the exact data from Lab 2. This is just some sample data, and I'm trying to do the same things that you're going to have to do with your Lab 2 data. So I've typed in some data here, and I've put some headings on the chart. The concentration is going to be our x-axis. That's what we're controlling. That's the independent variable. We have made these solutions of these concentrations, and then we saw what happened with the density. So that's the dependent variable. That's the one that we did not control. We just saw what happens when we made a solution with this concentration. Let's measure the density and see what happened. So this should be the x, and this should be the y. I'm selecting things with the titles because I think that when you insert a chart, that can make things a little faster for you. There's an icon here for insert chart, and there's also an insert menu that you can insert a chart. There's different chart types that you can do. It looks like it picked a scatter chart for you. That's what I want. If it picks one of these other charts with lines or bars, make sure it's a scatter chart, and it should just have the dots and not any lines trying to connect those. Then we have the data range. It has already set up a title for you. The title should be the thing that you're measuring on the Y versus the thing that you're measuring on the X. So if you did not set it up with a title, okay, so I put customize, and then we have the titles. I don't think we need the units in the overall title of the graph. We do want the units on the X and Y axes, so I modified that slightly. I still have the chart editor open, and I have it on customized. There's a lot of different things that you can do here. If you did not get the axis titles to show up correctly, that could be under chart and axis titles. You can edit this. I already edited the chart title. If I wanted to change, let's change this one. We'll just call this concentration because later I'm going to put concentration of B on here as well. So just concentration mass percent is fine. Density is fine for the vertical axis title. You should have the units, so you can change that. The series, if you don't like the dots, you can change the color. You can change it from a circle to another shape. You can make it smaller or bigger. So for the grid lines and ticks, I noticed that you can put some more lines on here if you want. I kind of like how that looks with a little barrier on the left, so you can mess around with how that looks. One thing I would like to check out on the vertical axis is the minimum and maximum. All of our data is in the top third of the graph, so maybe instead of graphing from 0 to 1.5, we can graph from 0.5 to 1.5. We can even spread it out more. So you can change the axis numbers if you want to have your data spread out a little bit more. If you ever notice that all of your data is clumped up in one place, you should change the scale of the axis to make it more spread out. Back under series, we do want to insert a trend line. So that is the best fit line to our data point. You can change the color of the line if you want. It should be linear for most of our labs. There is one lab coming later on where it's not. I'll warn you about that. You can change how it looks, make it thinner, make it darker. And we do want to use the equation. We want to show the equation, and we also want to show the R squared value. Those are some things we need to do for the lab. If there's something that you forgot to put on your chart or something you still want to change in your chart, if you double click on the chart editor comes up again, and you can do all the same things we saw before. If you single click, a menu comes up and you can edit the chart. It also calls up the chart editor. So there's a lot of stuff in this menu, this chart editor, that you might need. One thing that's a little bit easier in Google Docs than in the other graphing programs is that the trend line keeps going. And so in part A, we do have a part where we want to see the trend line go past the data points. And for Google Sheets, all you have to do is change the axis. We'll change the x-axis, and then the line will get extended a little bit further. So we'll customize again our axis, the horizontal axis. Let's have it start at 5. We can even have it start at 0. Okay. And the reason we did that is because there's a question, I think 6a, where graphically you want to see for a given y value that's outside of your y value, so a little bit lower y value, you want to know what the x value is. So you want to be able to follow this value to the chart and drop down. So you need this line to go past where the dots are. So for questions 5a and 6a, you're supposed to use this graph to visually find the answers to some questions. What this graph is really doing is changing from having just 6 data points, so we have just 6 data points, now we have a line which has an infinite number of data points. So before, if we wanted to find the relationship between 22.7 mass percent concentration and the density, we could have just looked at the chart. 22.7 mass percent is a density of 1.08 grams per milliliter. What if we want something that we don't have a data point for, like what about 30 mass percent? Well, we could look at the x-axis, follow it up to the line. Right here we find the point that is the relationship between the mass percent and the density for a mass percent of 30. And if we want to know what the density of that point is, that's the y value. We proceed over to the y-axis, and we can see that it's between 1 and 1.25. It looks like it might be a little bit less than 1.2. So if we had the y-axis marked with a few more ticks, we could maybe figure that out more precisely, but that's the process for doing it. Then for 6a, we are given a y value, again, that's outside of our range of data. Let's say that we're given a y value of 0.95, which would be about here. 0.95 density, we want to know what the concentration is. We would follow that over to the line. For a y value of 0.95, the dot that's on that line has an x value of about 7%. So we can do that visually. Then for 5b and 6b, we're going to do that using the actual equation, and we're going to calculate it. But to do it visually, I did want you to include the lines on the graph showing how you did it visually. Let's select the whole graph and copy it. Now I'm going to a Google Doc, and I'm going to go ahead and paste it. So when I paste it, you can either paste it linked to the spreadsheet. That means that any changes you make to your data or your graph on your spreadsheet will also change your document. Or you could paste it unlinked, meaning that any changes you make to your spreadsheet will not affect this document. So it depends what you want to do. If you want to use those same cells to do part B and part C, then maybe you don't want it linked because you don't want it to change every time you make a change to your spreadsheet. So then you can paste. So for parts B and C, we're just going to paste the graph as it is. For part A, I found that drawing lines on the graph doesn't work in the document itself. What we have to do is insert a drawing. So we insert a new drawing, and then we paste the chart here. Again, I'm going to paste it unlinked. So now the chart is in our drawing, and we can put some lines on there. So for 5A, we're taking an X value, following it up to our line. So we need a line there. You can choose a color. And then we want to have another line going across to the y value. For question 6a, we have a certain y value that we want to follow over. Let's put another line in there. And then we want one last line dropping down to our x-axis. So for 5a and for 6a, we want to show what we're doing visually on this graph with these lines over here. So then when we save it, it gets inserted into the document with the lines on there. I couldn't figure out another way to put the lines on after the graph was inserted, so I think that's a good way to do it. So these are the things that we needed for part A: a graph with the data on there, a best fit line going through the data, an equation showing, an r-squared value showing, a graph title, the axis titles density with the units and concentration with the units, and then some lines drawn on there to show the answers to questions 5a and 6a. For part B, having two sets of data on the same graph is something that's not as easy in Google Sheets as it is in other spreadsheet programs, because Google Sheets doesn't have a way to put a second set of data with different x values. They have a way to add additional sets of y values, but they don't have a way to add additional sets of x values. So I'm going to put all of these in the same column in order to make my chart in the first. So I will put this over here. I'm also going to change this to say just concentration, because that is just the concentration. Here's the density. And then these values are the concentration of B, and I'm going to put them under there. And then the densities, I'm going to put one column over. So now we have two different sets of data to go along with concentrations. And I'll start by making a graph with all of our x values and just the y values for substance A, the first one that we want to plot. So that way it has all the x values that we're going to need, but the y values over here are blank because that's not substance A. So we'll just plot this. I'll insert a chart. The first thing we want to do is change this from a line chart to a scatter chart. And that helps it to realize that this is a relationship. It's not just a bunch of things we want listed, which is what it did at first. So we have a relationship between the density and the concentration. And it looks like the axis titles came out well. And I want to add this data. This data is not on the graph yet. I want to put that on there. And I'm going to select this whole row for the data for part B. We have two sets of data on the same graph. Now we just have to add some different elements, some lines to make the chart look better. Maybe also expand this axis. Okay, for the labels of our sets of data, it's maybe not ideal. The blue dots are substance A and the red dots are substance B. Instead, it just put what I had in those boxes at the top. I had density in one box, I had nothing in the other box. If you select this and double click on the density, I'm going to go ahead and change this to substance A, because that's the density and mass percent concentration of substance A. This one doesn't have a label. The axis titles look okay. They have what you're measuring and the units. The chart title I don't think we need the units in the chart title. The chart title should be what you're measuring on the y-axis versus what you're measuring on the x-axis. So it looks like if you select those boxes, Google Sheets does a pretty good job automatically. Okay, so we need a little bit, I think I want to spread this out a little bit more on the vertical axis. And we'll show the axis line. That looks better. Now all that we need is to have our best fit lines and our equations and our R-squared values. So we can apply to all series, or if you just want to do something to substance A data or substance B data, you could. You can change the color or the shape of the dots, but what we want is a trend line. It should be linear. And we want that to be labeled with the equation so we can see what the equation is. And we also want to show the R-squared value. So it would be nice if this dot could get down here next to the line, but I can't seem to do that. But we do have the equations and we do have the R-squared values. So I think that is all we need for part B. I copied it. I'll put it in the document, unlinked, and now we have the graph for part B. Let's take a look at what we're doing for part C of the lab. In addition to a graph, I'm also asking for you to use the spreadsheet to calculate the average and the standard deviation of two sets of data. So again, my data is not an exact match with yours. I have two different scales that are measuring a bunch of mass measurements. So a bunch of kilogram measurements done with scale 1 and scale 2. For you, you have Lab 1 and Lab 2 students taking volume measurements. But for either of these, I went ahead and moved them over so that I could label these boxes as average and standard deviation. To get the average of this set of numbers, you can just start typing equals. So it's suggesting either the average or the sum. We do actually want the average of those numbers B18 to B27, the ones in those boxes. So we could go ahead and take their suggestion and press return, and that is the average. For the standard deviation, if it doesn't come up with the right suggestion, you can start typing ST for standard deviation. We want STDEV, and we do also want that to be from B18 to B27. We don't want to include B28 because that's not one of the values, that's the average. So I highlighted those cells. You could also just type in B18 colon B27 and press return, and that's your standard deviation. I'm going to select these boxes, copy them, and put them here. And you'll notice that here, instead of using B18 through B27, the program was smart and figured, well, you probably want these next pieces of data. So it's averaging C18 to C27 and also taking the standard deviation of those. So I just copied and pasted, and the formulas carried over. So we can tell that the averages are really close together. We can also tell that the standard deviation for this second set is smaller. That means that these numbers are more tightly grouped. It's kind of hard to tell just from the list, but you can tell from the standard deviation. Another way that's easy to see that is with a graphical representation of these data points. You can tell visually when data points are more spread out or more close or closer together. So let's do that. The way we want the graph to look is to really be a graph of the scale used versus the mass measurement. It's not a graph of the scale 1 values versus the scale 2 values. These are not connected. We don't want this on the X and this on the Y. We want the scale used on the X. And the first 10 measurements come from scale 1. I'll copy those. and the next set come from scale 2. I'll put those below here. So we have 10 data points from scale 1 and 10 from scale 2. Let's go ahead and make a scatter plot out of that data. So insert chart, you could also do it from here. It looks like it did select a scatter chart. That's good. It looks a little strange, but I think that's just because the data is not spread out very much on this chart. Other than that, I think that the title is pretty good. The axis titles are pretty good. We'll just fix the actual scales of the axis. Let's do that. All right, this looks better. Going from 0 to 3, now we have a scale 1 and a scale 2 set of data points. We need to spread them out now, so let's fix the vertical axis. That's a big issue. All of our values are between 60 and 70 kilograms, so let's do that and see what happens. Okay, I think we could spread it out a little bit more. Let's go between 62 and 68. So that's pretty good. You could spread it out a little bit more if you wanted to. Okay, so none of the data points are off the chart here. This is the lowest one, so we haven't cut it off. We wouldn't want to start at 64 and cut off the data point, but starting at 63 is okay. Going to 66 would even be okay if you wanted to. All right, so this helps us visually see what we said before, that the scale 2 data points are closer together. They have a smaller standard deviation. The larger standard deviation for scale 1 shows that the values are more spread out, and you can tell that with the graph. Another thing that's easier to see with the graph, not with the list of numbers, is whether there's a data point that is a little bit far from the rest. I think if you click on the point, you can see which one it is, or if you hover over the point, the 63.44 is a little bit farther from the others for scale 1, and the 65.66 is a little bit far for scale 2, because there are some questions in the lab about whether data points look like they're far from the group, and then a way to check on whether those data points are actually outliers or not. But as far as the graph goes, this is looking pretty good. It has a title, it has axis titles, and the data is spread out. We do not want to put a trend line for this data. We are not trying to establish a linear relationship, so this should not have a trend line for this particular chart. We do have the average and standard deviations over here, so we want this and we want this chart. I'll put that in the document as well. And the lab report this time is pretty much a series of graphs. Of course, you want your name and your section number on there, and then for each part you want a graph and then some answers to some questions. I have some bullet points over here. I think for part A you want questions 1 through 6. For part B, I have the graph. This bullet point thing started again at 1. I think if you right click it, you can continue the previous number. So unfortunately, so if we had 6 here in part A, then part B would start with 7. I think part B goes from 7 to 11. We have our part C graph, and then after that we want the rest of the questions. So our bullet point, and 12 through 15 for part C, I believe. And then that would be the lab report. Oh, also you want it to save it as a PDF. Let's go ahead and do that. If you go to File and Download, you should be able to save it as a PDF once you're done. You try opening it. I mean, I didn't finish answering the questions from my example, but it looks like This is pretty good as far as a PDF that you can upload to Canvas.